Hi everyone, and welcome to this video on the periodic table. For this lesson, you're going to need a paper copy of the periodic table, or if you prefer, you can find a copy on Teams and you can write notes on it on your computer. So you need the periodic table, you need something to write with, and you need two colors, highlighters or markers or pencil crayons. So pause the video and go get those things. Okay, let's get started. So we're going to talk about kind of why the periodic table looks like this at first. So on the periodic table, you have symbols representing elements, and you'll notice that all these symbols have a capital letter at the start, but then all the letters that follow are lowercase. This is so that you can tell where a new element starts. So every time you see a new element, it will start with a capital letter. On the back of the periodic table, there is an alphabetical listing of the elements because sometimes it can be hard to find the elements, especially ones where their symbol doesn't match their name. So for example, if you were looking for lead, you would say, okay, here's lead, it's number 82. On this side, you'll notice that the elements are organized by what's called their atomic number. So here's 80, 81, 82, there's lead. Lead's PB. So if it's hard to find, you can just look at the back. Early periodic tables were organized by the chemical and physical properties of the elements, but the modern periodic table is in numerical order based on their atomic number. So if you forget what number means what, this is a key. So you can tell the atomic number is in the top left corner. Followed by the symbol, which is the short 2 or 3 letter version of an element's name. There's its name. This is the atomic mass. This is also called the average atomic mass because you can't actually have an element that weighs point something. It always has to be a whole number. But some atoms of titanium weigh 48 and some weigh 47, so this is an average. Up here in the corner is the ion charge. This tells you how many electrons are lost or gained when it makes an ion, which will come in a future lesson. So the elements are organized by their atomic number. Their atomic number is also the number of protons you find in the nucleus of one of these atoms. So hydrogen is quite small, it only has 1 proton, versus something like mercury, which has 80 protons and has quite a large nucleus. There's a couple other things you need to know about the periodic table. When we talk about columns on the periodic table, these are called groups. So let's write that up here. A vertical column is called either a group, it can also be called a family. And you'll find that elements in the same group have similar chemical and physical properties because their arrangement of their electrons is similar. So if I am referring to group 2 on the periodic table, it means the ones with the 2 at the top. The second column is group 2. You should write group or family with an arrow to show that it's the column. The other word that we use to describe a row is a period. Right? Periodic table, they're organized in periods, which means a row. So this is the period starting with potassium. Okay, it goes all the way over. This is all the same period. They also share some properties based on their electron arrangements, but the stronger tie is the group or the family. The last thing for today that you need to label on the periodic table is it's partially labeled for you. You can see that the table is split into metals and non-metals. So everything, you see here this arrow, and then it has this kind of staircase line. So the things on the left-hand side of the periodic table are called metals. The things on the right-hand side of the periodic table are called non-metals. And metals and non-metals share certain properties. In the middle, there's something called a metalloid, and a metalloid means basically it's not quite a metal or a non-metal. So what we're going to do is take one of our colors, we're going to highlight the metalloids. So your metalloids are boron and silicon, germanium and arsenic, antimony and tellurium, and polonium and acetine. Okay, so these are metalloids. So what I'm going to do is write metalloids at the top and highlight it with my color so that I know that is, that's what that means. Nonmetals are on the right-hand side of the periodic table. So they're all the ones that are above these stairs that we just haven't colored in for metalloids. So here we go, just gonna highlight these. We're gonna stop at radon. These ones at the bottom that have brackets, they're they're called synthetic elements, and they're ones that have been made in a lab but not found in nature, and they're kind of unstable. So we're gonna stick to the ones that we know more about. Radon, it has brackets, but it's because it's unstable, so it gives off nuclear radiation. Okay, so metals, we're not going to color them in because there's way too many of them, but they are usually solid, they're usually shiny, they're usually great conductors of heat and electricity, meaning heat or electricity can pass through them. They're usually quite malleable, meaning you can bend them without them breaking. And they're ductile, meaning you can stretch it out to make a wire with it. Nonmetals, on the other hand, some are gases, some are solids. Bromine here is a liquid at room temperature. And the metalloids are all solids at room temperature. Nonmetals are not very shiny. They're bad conductors of heat and electricity, and they're hard to shape into things. They're quite brittle. And they're not ductile. And I forgot to highlight hydrogen. Hydrogen can act as a nonmetal, but it can also act like a metal, so it's on both sides of the periodic table. Metalloids, like I said, are solid at room temperature. They can have the properties of either nonmetals or metals. So they can be either shiny or dull. They might conduct electricity, but they don't really conduct heat very well. And they're usually brittle, like a non-metal. So metalloid refers to the fact that they're not really one or the other. There's something in between. Great, I hope that's clear. Go ahead and do the practice in your workbook and let me know if you have any questions.